Engineering Glass here. Now, today's topic is, where does electricity come from? Now, you may have electricity in a lot of your devices at home. You may have it in your computer. You may have it in your refrigerator. You may even have it in your toaster. So, you can have it in a receptacle in your outlet at your house. So, where does it come from? Because sometimes you don't know. I mean, it comes from somewhere. It comes from the street. But where does it really, in essence, come from? Well, in short, it comes from metals. Believe it or not, you get a metal, and if you do a little magic, do a little dance, you can make electricity come out. But these aren't just ordinary metals. These are special types of metals. So let's just say we have a metal, this special type of metal, and it's a bar, right? Okay, you have this special type of metal, and it's a bar, and you can't find this anywhere in the world. You can only find it some places, very, very select locations in the world. That metal will be able to emanate this electromagnetic field. It's able to absorb a magnetic field, electromagnetic field, and it's able to emit these waves, these rays emanating out from it. But it's only for a certain, area, right? So let's say sometimes, depending on how big the material is, it might just be for about 3 or 4 feet, right? So if you have this metal, you can get another metal. You can get something like a coin, usually like a very conductive coin. Okay, and you can have maybe gold, copper, aluminum, any type of metal like that. And it doesn't really have to be a coin. It could be just any type of metal. But that's usually the metal that people have the most. So we'll just use that as an example. And you could take that piece of metal that you have, which might very well be a coin, and you could just move it across those invisible lines of electromagnetism emanating out from that ferromagnetic material, which is the material, that special material that I didn't tell you before. It's that bar. It's called ferromagnetic material. So you move it across those lines, those invisible lines, and at certain points, those two lines, one from the metal that you have, that coin or whatever piece of metal you have, and the ferromagnetic material, they'll intersect and they'll create some interaction. That interaction is a basis of electricity. So when you have that interaction, what you'll actually have is, you can have like a piece of wire, as long as that wire is conductive, right? If that wire is conductive, that energy, all that energy of those two worlds colliding, will cause this current to flow through that piece of wire. And again, this only happens when you have this ferromagnetic material. You may ask me, okay, but what is ferromagnetic? How do I know I have ferromagnetic in my house? I might have it somewhere. So let me just go through a little explanation. Ferro, you can kind of guess where it comes from. It's hierro in Spanish, it's fierro in Latin, and it's iron in English. So you can kind of see the etymology of it as you roll down. So it's iron, usually iron based. I mean, it could be different metals, but it's, if you get iron, you're good. So if you have that wire that I just drew, those blue dots are current. Okay, now you have current flowing through that wire. Okay, that is electricity. Current flow is the electricity that we're talking about. And so you basically completed your task of creating electricity. So that's it. You have it. And you may ask yourself, wow, that's all I need. I might just go buy a ferromagnetic material and get some copper and create some electrical machine. But remember, a lot of these materials are so rare, they cost a lot of money. So these aren't just ordinary household materials. So you have to take that in consideration. But anyway, when we think about electricity, the next step or the next phase we're kind of thinking about, the next level is, okay, we need to have a goal. How do we actually create electricity? You can create this manually, but how do we create it automatically? And that's one of the big goals of electrical engineering. You have to decide, okay, what's the most efficient way, efficient meaning using the least amount of energy to get the most amount of current through that wire. So that's a big task, and it's a different video. A lot of people have thought about this, but essentially the problem or the objective is to make it to where that piece of metal will continually cross those lines of flux. So there's all these different kind of convoluted ways to do that. But if you can just think about that, and if you can create a solution, then you have a great way of generating electricity. Usually, people rotate it, because just think about a wheel on your bicycle and think about like a reflector, how it rotates around the spoke. You're constantly going around that piece of metal in the center. So that's a great way to do it. But that's, like I said, that's a different discussion, probably different videos. So just watch out for that. Okay, and as I said before, as the conductivity of a material goes up, also the cost goes up. And three of the most conductive materials are silver, copper, gold. And so, as you can see, those cost a lot of money, and they're also good conductors. So that's the kind of dilemma. And at the bottom, you have things like paper, wood. But, paper and wood, everyone has paper, wood. But at the same time, it's not going to do you any good because they don't really conduct any electricity, right? So that's why a lot of things cost a lot of money. That's why electronics cost a lot of money, because they need to have these special materials. So talking about these special materials, where do you get them? That's the goal. I mean, we want to know where we can get this stuff. Maybe if you live somewhere in the world, you can just step outside your house, go digging a little bit, you can find these materials, and you can build your machine. And you very, very well may be right. So let's just draw a map of the world right quick. We draw the United States, we draw Central America, and we draw South America. Let's draw Greenland. Let's not forget them. Europe is in here. And very shortly, we'll draw the continent of Africa. We need to draw Scandinavia. So while I do this, you'll realize that there are some places in the world that have these materials. So these are very, very coveted areas. And I'm going to put the points on the map. And if you live in these areas, you might be one of the lucky people who might be able to build your own electrical machine that can generate electricity. So, as I point out here, we have some in Peru, we have some in Ecuador, we have some in Ghana, we have some in maybe Congo and South Africa. So a lot of these places have gold, right? And Sudan has gold. Uzbekistan, they're present over here. They have gold. Let me see who else. Alaska, California has some. Nevada, Colorado, they all have some gold, right? So a lot of these places also have copper, and they also have iron. So a lot of those materials, a lot of those rich materials also, occur in the same place. A long time ago, what people used to do, since you see there's nothing in Europe, a lot of people in Europe used to go to places where they did have those materials. So they used to go to South America, they used to go to the coast of Africa, they used to go to all these places because these are very important industrial metals that you need to really create industry. When I mean by industry, I mean like creating machinery, creating electrical machinery, mechanical machinery, all different types of machinery that are very important for the industrialization of your country. So, I forgot one country here. I forgot Australia. Australia also has some gold, iron, and they also have copper. So they're in it too, and they're another